Okay, welcome to tonight's session. So in this session, like I said, I promised to say we're going to have a tutorial where I'll just solve some questions based on what we have covered so far. And then apart from that, I think the questions that I've put in this session, they're all from your handout. Yeah, so I think I'll take time, probably tomorrow, yes, to pick out some questions from your assignments so that we can come and do them together as well. Okay, so let's quickly begin. So we have this question here which says, if A is equal to that, B is 2, 4, 6, 8, C is 3, 4, 5, 6, and the universal set X is from 0 to 10. The first question is asking us to find A intersection B. And then the second question is asking us to find A intersection B complement. And then the third question is asking us to find A union B complement. Okay, so these questions are very simple and straightforward. So let us see how we're going to deal with this question. So the first one there, the first thing that we need to put in mind is that we've been given the universal set. So the universal set is simply, simply contains numbers from 0 up to 10. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the first question there is asking us to find A intersection B. So how do you find A intersection B, given that A is, okay, let me just write all the sets. So we have A is equal to, we have 2, 3, 4, 5. Then set B is equal to 2, 4, 6, 8. And we also have set C. So set C is 3, 4, 5, 6. We have 3, 4, 5, 6. So these are the three sets that we've been given. So now we've been asked to find A intersection B. So A intersection B, remember what I said, whenever we're dealing with this symbol, the intersection symbol, we're simply talking about the common elements. So common elements between A and B are the ones that we denote as A intersection B. So this set we're trying to find is simply just a set of common elements that are in A and B. So we look at the elements that are common. So the elements that are common here between A and B. So we have, the first one is 2, we have 2 there. There's also another 2 there. So we have 2 in A, we also have 2 in B. So we can write 2 there as one of our solutions. Then we say comma, we look for another common elements. Do we have 3 there? Yes. Do we have 3 there? No, we don't have in B. Do we have 4 there? Yes. Do we have 4 in B? Yes. So 4 is also common. Which other element is common? So that's so. These are the only 2 elements that are common between A and B. So we close the bracket. So this is the solution for the first part. So when you talk about intersection, we're simply talking about the common elements between the given sets. So we've also been asked to find A intersection B complement. So what this simply means is that we're going to list the elements that are not in A intersection B, but they are present in the universal set. So elements that are not in A intersection B, so elements that are not in A intersection B, but they are present in the universal set. So which elements are those? So these elements are, so in other words, we're trying to list the whole universal set excluding A intersection B. So we write the whole universal set excluding A intersection B. So the first element we have there is 0. The second one is 1. The third one is 2. But since 2 is present in A intersection B, we're not going to write it because we're trying to list the complement of this set. So we skip 2. Do we have 3 in A intersection B? No, so we write it there. Do we have 4 in A intersection B? Yes, so we skip it. Do we have 5? No, so all the numbers that are not in A intersection B, we write them there because we're looking for the complement of A intersection B. So these are the common, this is the complement of A intersection B. So we proceed to A union B complement. So A union B complement, the first thing that you need to find is A union B before we find its complement. So A union B, whenever we talk about this symbol, which is the union symbol, we're simply talking about the addition of 2 sets. So the union symbol adds 2 sets. So when I say A union B, I mean we're going to combine A and B. So we have to combine set A and set B, we put them together. So now as we put these sets together, we have to make sure that all the common elements are listed only once. So you don't have to repeat the same element 2 times. So for instance, we have 2 and another 2 there. So I'm not going to write 2, another 2 there. No, I'll just write 1, 2. So I'm not supposed to repeat the same element 2 times. Then we have 3 there, so we can write 3. Then we have 4 there, can write 4. And we have 5, can write 5. Then we have 6 there and 8. So we write 6 and 8. So this is our A union B. So now how do we find A union B complement? So we have found A union B. Now we're trying to find A union B complement. Now A union B complement is simple. What this means is that we're going to list the elements that are in the universal set, excluding those that are in A union B. So in other words, we're going to subtract A union B from what? From the universal set. And then the remaining numbers, rather the remaining elements are the ones that we're going to write there. So we have 0 and then we have 2 there. So we can write 0 and 2. Oh, sorry, there is not 2, we have 1 there. So we can write 0 and 1 because 2 is present there, we'll not write it in the complement. 3 is present in A union B, so it's not supposed to be in the complement. 4, 5, 6, they are not supposed to be in the, rather, they are not supposed to be, in the, these are not supposed to be in the complement because they are present in the main set. So we have 7. 7 is not in A union B, so we're going to write 7 there. Then there is 8 there, so we're not going to write 8 because it's present in the main set. Then there's also 9 and 10. So there's also 9 and 10. So this is our A union B complement. So before I erase, last time there was a concern that I should be allowing you people to ask questions where you do not understand. So before I can proceed, do we have anyone with a question? Before I go to part 4, 5, and 6, do we have anyone with a question? Okay, so silence means that everyone is clear. Okay, so we proceed to the next one. So the next one is A intersection B minus C. So remember what I told you, that whenever you see B minus C, or let me start with A minus B. Whenever you say we see A minus B, this simply means that we're trying to find, okay, A minus B means that we're trying to find A intersection B complement. So when we say B minus C is simply just B intersection what? C complement. So this is what we're going to start with. And the reason why I'm starting with this is because whenever you're dealing with any mathematical problem, you always have to follow what is known as BODMAS. So this BODMAS means brackets of division, multiplication, addition, and subtraction. So I'm going to start with what is in the brackets because B is the one that begins in BODMAS. So we start with what is in the brackets to solve this question. So we're going to start with first finding what? B minus C. So B minus C, as I said, is just the same as B intersection C complement. So B minus C is just the same as B intersection C complement. So having done this, we can now find what C complement is so that we come and intersect it with what? With B. So C complement. So C complement is simply just listing the elements that are in the universal set, but they are not in C. Or in other words, we try to list all the elements that are outside C, but they are present in the universal set. So C is 3, 4, 5, 6. So meaning the universal set, if we check the universal set, we have numbers starting from 0 up to 10. And then C is simply just 3, 4, 5, 6, meaning C complement will be anything that is not in C. So anything that is in the universal set but is not in C is going to be our C complement. So we have 0, 0 is not part of C. And then we have 1 is not part of C. We have 2 is not part of C. And then 3, 4, 5, 6, and then we have 7, 8, 9, and 10. So this is our C complement. So now we're trying to find the common elements between what? B and C complement. Let me also write B here. So B is simply just 2, 4, 6, 8. So this is our B. Now trying to find the common elements between C complement and B. This is what it is. I mean, this question is asking us here. So we find our B, B minus. So B minus C will simply just be equal to the common elements between B and C complement. So the common elements here that we have 2 there and 2 there. The other one is 8. We have 8. So we only have 2, 2, 8. So we only have 2 elements that are common. So now, having found B minus C, let us also intersect it with what? With A. So let me write my set A there. So set A is 2, 3, 4, 5. So set A is 2, 3, 4, 5. So now trying to find the common elements between what? B minus C and A. This is what we have here. Trying to find the intersection between A and what? B minus C. So now let us find our A intersection B minus C, which is our final solution. So our final solution is just the common elements between this set B minus C and A. So when you check the two sets, you discover that the only common element there is what? Is 2. We have 2 there, we also have 2 there. We have 8 there, we don't have 8 there. So the only common element is 2 there. So I'm going to write my 2 there as my set. So this is a singleton set because it contains only one element. So remember what I said, a singleton set only has one element. So this is the solution to this question. Do we have any questions before I proceed to this one? Okay, so we proceed. Okay, so we proceed. So we proceed to the next question. The next question is simply x minus c, and then this one has a complement outside, and then we're trying to find the intersection between x minus c and a minus b. Now trying to find the intersection there. So what do we do? So the first thing is to work with what is in the brackets. So I'm going to start with this set of brackets and then that. So when I open the brackets here, what am I going to have? Or even before I open, let me first find what is inside the brackets there. So I have x minus c. So x minus c is simply just x intersection c complement. So having found that, we can now just, yeah, so having found this, we can now find what C complement is, and then we intersect it with what? With the universal set. But remember what we said, according to the rules of sets, we said the universal set, intersection, if you remember those rules that we went through, the universal set, intersection, any set here gives us what? That same set. Whether this set is a complement, the answer will still be the complement. So X minus C will simply just give us what? C complement. So X intersection C complement will give us what? C complement. The reason why it's giving me C complement is simply because X is what? Is a universal set. So having this there is just the same as just having C complement. So we have C complement there, and then there's also another complement outside there. So we write it there. Then we say this is intersecting with what? Our A minus B. So complement and complement, when you open, this cancels with that. So we just remain with what? C intersection A minus B. But remember, this A minus B can also be written as what? A minus B can also be written as A intersection B complement. So having this, yeah, so having this as the simplified version.
Oh, sorry. Hello.
Oh, sorry. I've seen something. I'm
Yeah.
sure
Yes.
Okay. Yeah. Right. So A minus B can be written as A intersection B complement. So now our set A has been given in the question there, which is 2, 3, 4. And then we have 5 there. And then our B complement is simply just going to be equal to what? So B complement is going to be equal to whatever that is in the universal set, excluding a B. So we're trying to look at the elements that are outside B, but they are in the universal set. So which one is my B? So B is simply just, if you look at the sets, B is this set here. So I'm going to write everything that is not in this set, but they are present in the universal set. That is what we call B complement. So B complement will therefore be, we have 0, we have 1, then we have, so 2 is present in B, so I'm not going to write 2. Then we have 3, then 4 is present, I'm not going to write 4. Then we have 5, 6 is present in set B, so I'm not going to write it. So I'm going to write 7 there. 8 is present in the B, in set B, so it's not going to be in the complement. So we leave it. So we skip it, we go to 9. Then the last one is 10. So this is our B complement. So now to find A intersection B complement, we therefore get the common elements between B complement and A. So the common elements here, we have 3. 3 is common there. Then the other one is what? We have 5. 5 is also common. So the A intersection B complement is simply just 3, 5, because 3 and 5 are common. So this is our A intersection B complement. So our A minus B is therefore equal to 3, 5. So now this 3, 5 is what we're trying to find, what we're going to intersect with what? With C. So the final solution will therefore be equal to C intersection A minus B is therefore going to be equal to what? So we find the common elements between this set and set C. So set C has been given in the question. When you look at the question there, our set C, let me just write it here. Set C is given to be 3, 4, 5, 6. So we have 3, 4, 5, 6. So this is our set C. So now we're trying to find the common elements between A minus B and set C. So the common elements here, we have 3 and 5 only. So we write our 3 and 5 there. So this is our C intersection A minus B. Therefore, you can conclude to say, you can conclude to say our X minus C complement intersection A minus B. The answer is simply just 3, 5. Do we have any questions on this one? Okay, so we proceed to the next question. So the last question here is B complement. So B complement is simple because I think I've even solved it in one of these same questions there. So B complement simply means that we have to list all the elements that are in the universal set, excluding those that are in B. So our B, set B has been given to be 2, 4, 6, 8. So this is our set B. Now to find B complement, we have to write everything that is in the universal set, and the universal set has been given to be X. So we write everything that is in X there, excluding what is in B. So we can write starting from 0, we have 0 in X, we have 1 in X, we have 2 in X, sorry, we have 2 there. So meaning we don't have to write it in the complement of B. So we leave out 2. We have 3, we have 4. 4 is part of set B, so we're not going to write it in the B complement. Then we'll have 5, we have 7, we have 9, and we have 10. So this is our B complement. We have listed the universal set excluding what? Set B. All right, so this is exactly what you people are supposed to do when you are faced with such a question. Okay, let us quickly move on to the next question. So this is our next question. Okay. So they're saying using the same sets above, confirm the associative law that A intersection B intersection C is equal to A intersection B intersection C. So I'm not going to solve all the questions on this one. So I'll only solve, I think, one question on each question here. Yeah, and then the remaining ones you can do them as practice exercise. So the first one there, we're trying to prove that A intersection B intersection C is equal to what? A intersection B intersection C. So now we're trying to prove that this is equal to that. So here, when you're dealing with associative, remember what I said, you only just consider you only just consider the position of brackets. So associative just talks about the position of brackets. You can see that we've changed the brackets from these two letters, from these two sets to B and C there. So what this means is that we can first start with the left-hand side. If you are proving, you can start with either the left or the right, depending with which one seems to be more complicated. So we start with the left-hand side. So the left-hand side is simply just this part, which says A intersection B, then intersection C, but the brackets will first be here. So what this means is that we first have to find what? A intersection B. So A intersection B from these two sets, from these sets that we've been given, we found A intersection B as what? As you look at the common elements from these sets. So the common elements there, we have 2, then we have 4. So this was our A intersection B. So it's 2, 4. So we have 2, 4 there. Then we're intersecting this with what? With set C. So what is set C? Set C is simply just 3, 4, 5, 6. So 3, 4, 5, 6 is our set C. So now I'm trying to find the common elements between this and that set. So the common elements there we have is, I think, only 4, because there's 4 there and there's 4 there. So this is our A intersection B intersection C, or let me just write it as the left-hand side. So this is our left-hand side. So let us also take the right-hand side. So the right-hand side is just what we have this side. So we also start with, by dealing with what is in the brackets first. So we start with B intersection what? We start with B intersection C. So B intersection C, let me demarcate here so that we don't confuse the two. So B intersection C, from these sets that we've been given, B intersection C is simply just the common elements between B and C. So in B and C, the only common elements that we have there are what? We have 4 there. You can see that 4 is common between B and C. And then the other common element is what? Is 6. So we only have 2 there. We have 4 and 6. So, okay, so this is what we have. These are the 2 common elements that we have. We have 4 and 6. So our B intersection C contains 4 and 6. So we're saying A intersecting with 4 and 6. So I'm going to use these brackets. So don't make a mistake to use these brackets. So when you're listing a set in roster notation, you use this kind of brackets. So this is what we have as our B intersection C. So after finding this, let us find the common elements between A and B intersection C. So which one is our set A? So our set A is 2, 3, 4, 5 from the sets that we are given. 2, 3, 4, 5. So we have 2, 3, 4, 5. So this is our set A. Then we're trying to find the intersection set between A and B. So now, let us now find the common elements between this set and that set. So the common elements, as you can see here, we only have 4 there and 4 there. So this is the only element that is common. So we have found that the left-hand side, this one, and the right-hand sides are equal. So you can now conclude to say, since the left-hand side is equal to the right-hand side, then, you just say hence confirmed, because they're asking us to confirm. So you've confirmed the first part. So in other words, what they're trying to say here is that you are simply just solving. Yeah, that's all. You're simply just solving. All right, so let us also pick one question from part 2. So part 2 there, we're trying to prove the distributive law. So the question there is A union B intersection C. They're trying to ask us that we prove or we show that this is equal to what? A union B intersection A union C. So the first thing that we can do here is to get the left-hand side.
Excuse me.
Yes.
On the associative law, after we found the 4, is there anything that is supposed to be indicated to say we have proved? So it's just a matter of solving and that's it.
That's it. That's why I'm saying these questions are simple. It's just a matter of solving the questions. That's all. What you just need to show them is that, you just tell them to say the left-hand side is equal to the right-hand side. Then you say hence confirmed, because they're asking us to confirm that. If it's proving, you say hence proved.
Okay, thank you.
All right. So that is what you are supposed to do. So now we get the left-hand side. So the left-hand side here is A union B intersection C. So the first thing that we do is to find B intersection C, so that we find A union, the set that we're going to find there. So let us find our B intersection C from these sets. So our B intersection C, okay, 7 here. It's 4,6. We've already found it. So we put our 4,6 there, and then A intersection 4,6. So our set A, let me write set A here. So set A is 2, 3, 4, 5. So we have 2, 3, 4, 5. So I'm trying to find the common elements between set A and 4,6. So what is common between this set and that set? So we don't have anything common here. Oh, we have 4, sorry. We have 4, which is common there. So we write 4 there as our solution. All right, so let us try to check also the right-hand side. So the right-hand side is simply just A union B, then intersection A union C. So the first thing that we need to find is what is in the brackets. We find A union B and A union C. So what is our A union B from these sets? So our A union B is therefore going to be, we add the two sets, set A and set B. So union is simply just addition of two sets. But as you are adding, when you are listing the sets, make sure that you don't repeat or you don't write the same element 2 times, even if it's appearing 2 times in the sets. So we have 2 there, 2. And then apart from that, we have 3, we have 4, we have 5, we have 6, we have 8. So this is our A union B. So we have 2, 3, 4, 5, 6, 8. So we have 2, 3, 4, 5, 6, 8. So this is our A union B. Let us also find our A union C. We're trying to combine 2 sets, set A and set C. So set A is 2, 3, 4, 5, and then set C is 3, 4, 5, 6. So we have 2, 3, 4, 5. And then in set C, we have 3, 4, 5, 6. So just adding 6 this side. So this is our A union C. We have 2, 3, 4, 5, 6. So we can write that. Are we doing the right thing? I'm trying to find A union what? A union C. I was combining B and C. So we've made a mistake. So I'm supposed to combine A and what? And C. So A and C, we're starting from what? 2. Then we have 3. And then from there we have 4. Then we have 5. So we have 2, 3, 4, 5, and 6. This is what we found, right? Yeah. And then this is our A union C. And then A union B, we said 2, 3, 4, 5, 6, 8. All right, so this is, okay, let's see. So we have 2, 3, 4, 5, 6. So we have 2, 3, 4, 5, 6. And then from there, we are now supposed to find, okay, we are now supposed to find the intersection between these two. Oh, sorry. There was a mistake here. I thought this was intersection, and no one could even notice that this is union. So in finding this, we're not supposed to find the common elements. Instead, we're supposed to add set A to this set. So our set A is here, so we add it to this set. So I'm just surprised the solution that I'm getting here and the solution that we have written here are not matching. So we're supposed to combine the two sets. So combining these two sets, A and this one here, we're going to have 2, 3, 4, 5, and 6. So the solution will be 2, 3, 4, 5, 6. So now let us finish up. So this one is the left-hand side. So now let us finish up the right-hand side. So the right-hand side will therefore be, we find the common elements between these two sets. So the common elements that we have there, we have 2. 2 is common there. Then we have 3 is common. We have 4 is common. We have 5 is common and 6 is common. So we have 2, 3, 4, 5, 6. So these are the common elements that we have. So now let us compare whether the left and the right hand side are the same. So you can see 2 there, there's 2 there. You can see 3 there, there's 3 there. You can see 4, 4, 5, 5, 6, 6. Hence, the left hand side is equal to the right hand side. And this implies that we have confirmed. Okay. So we do the same even for De Morgan's here. So we first have to find A union B.
Hello.
Congruent. Yes.
Sorry, I think I missed the last 2 classes we had. So I wanted to find out what's the difference between the associative law and well as the distributive law. Because from what you've explained, it seems
Okay,
the
so
formula is the same.
no, the formula is not the same. When you look at the associative law deals with you changing the brackets. Like if you check, the first brackets are here and the second brackets are on B and C. So us talking about the associative law, we're just trying to prove that even if you change the brackets, if you first put the brackets on the first 2 letters, the first 2 sets, the answer that you're going to get is supposed to be the same as the answer that you get after first finding the solution of B and C, and then you add A at the end. Then distributive will tell you to say anything that is in this format can be written in that format. Meaning what you have this side, if you find the solution this side, the answer will still be the same as the solution that you're going to find on the right-hand side.
Okay, so what you're trying to explain is the first one is basically they are giving you the same things, but then just interchanged.
Yeah.
But for the other one, you find that they give you 2 different questions, but then you still have to come up with the same answers.
Yes. The other thing you have to understand is that if they tell you to say, confirm that this is equal to this, or prove that this is equal to this, it means that they know to say this is equal to this. Now, they just want you to show.
So you can use either or. Okay.
Yeah, so the link is about to end. So we should join using the same link so that we at least cover some more questions. We can't just solve one question. So it's ending very soon. You should join using the same link